Today I am going to discuss about the topic electrostatics of conductors. The first point is electric field or the electrostatic field is always normal to the surface of a conductor. Look at the diagram here. We have a conductor. Let us assume that this conductor is an empty conductor. And as all of us learned that charges always resides on the surface of the conductor. And these charges are distributed uniformly over the surface. And here the point is, if electric field is not normal to the surface of the conductor, then what would happen? Look here. Suppose if electric field is along the tangential direction. If electric field is along the tangential direction, then these charges, the charges that are present on the surface would have experienced the force and they would have moved from one place to another place. But in static situation, the charges will be always at rest. Therefore, the electric field is normal to the surface, not along the tangential to the surface. Electric field is always normal to the surface. This is wrong. This is the first point. Second point is, inside the conductor, there are no charges. Even if charges are there in a solid conductor, but if you consider the elements of volume, the total charge of the conductor inside the surface will be zero. Suppose if you consider that this is a solid conductor. If you consider one element here, the total number of positive charges will be equal to total number of negative charges. Therefore, the net charge inside the conductor is zero. And the charges only reside on the surface of the conductor. As we know that the conductor carries the electricity through mobile charges, through free charges. That means charges only on the surface of the conductor. There are no charges inside the conductor because the total charge, the number of positive charges will be equal to the number of negative charges. Hence, the net charge inside the conductor is zero. The next point is about the electrostatic potential throughout the volume of the conductor is constant. As we learn that V is equal to KQ by R. And we also learned that V is equal to W by Q. If you consider the surface, at every point on the surface, the electric potential is same. Therefore, the potential difference between any 2 points here, suppose if you consider point A here and point B here, the potential at this point is VA, the potential at this point is VB, and the potential difference is equal to work done in taking the charge from point A to point B. Since potential is same, therefore potential difference is same. And therefore, work done in taking a charge from one point to another point on the surface of conductor is zero. Similarly, here also, if you take a charge from point C to point D inside the conductor, there also work done is zero. There is no work done in taking a charge from point C to point D inside the conductor. There is no work done. Therefore, inside the potential is same as that of the potential at the surface. Here also work done is zero. Here also work done is zero. But at the surface, the potential is V equal to kq by r. Therefore, the potential inside the surface should also be V is equal to kq by r. Because here also work done in taking the charge is zero from one point to another point. Here also work done in taking a charge from one point to another point is zero. But here there is an electric potential, that is V is equal to kq by r, and here also there must be a electric potential which is equal to this one. Therefore, the conclusion is this, that the electrostatic potential is constant throughout the volume of the conductor. Then the next point is about the electric field due to the surface. As we know that this is a conductor which has positive charges and they are distributed uniformly throughout the surface of the conductor. Assume that this is a solid conductor. Inside the solid conductor, the net charge is zero because the number of positive charges will be equal to number of negative charges. Here at the surface, the free charges are existing. The free charges are residing on the surface. If you consider one surface here having some pillbox this type, because of these charges there is an electric field. The electric field is normal to the surface. And what about the area vector of the surface? The area vector of the surface is also in the same direction. The electric field and area vector are in the same direction. Okay? Then what about the electric flux passing through this pillbox? Electric flux is equal to E dot ds, the dot product of two vectors, which is equal to E ds cos 0. The angle between the electric field and the area vector is 0. Cos 0 is 1. Therefore, E is equal to ds. Fine. The same electric flux can also be calculated by using Gauss theorem. Electric flux is equal to 1 by epsilon naught times the charge enclosed by the surface. Let us take the charge enclosed by the surface is dq. Fine. As we know that the charge per unit area, charge per unit area, this is unit area. In this unit area, the quantity of charge is dq. So charge per unit area is equal to surface charge density, which is denoted by sigma. Now, dq is equal to dq is equal to sigma into ds. Substitute the value of dq here in this equation, we get electric flux is equal to 1 by epsilon naught times the charge enclosed by this surface is dq. The dq is equal to sigma into ds. Now call this is equation number 1 and this is equation number 2. Compare these two equations. We get E into ds is equal to sigma by epsilon naught into ds. This ds cancels. What we get is E is equal to sigma by epsilon naught. This is the electric field due to a surface of the conductor. Fine. Now let us discuss about what is electrostatic shielding. Okay. The dictionary meaning of electrostatic shielding is an empty space protected from external influence of electric force. Look here, we have a conductor, a hollow conductor, empty conductor. This is the empty space. As we learned that the charge inside the conductor is 0. Wherever charges are there, there is electric field. But here no charge, no electric field. But there is a electrostatic potential which is equal to the electrostatic potential at the surface. That is VO. VO means what? Electrostatic potential at the surface. Here, the charges are residing on the surface of a conductor. The charges are residing on the surface of a conductor. Okay. Now, look at this diagram. This empty space has no charge. Therefore, this empty space can be protected from the external electrical influence. Even though there are charges here, this electric force does not affect this space. So this space, this cavity is protected from the external electrical influence, and this can be used to protect sensitive instruments like a moving coil galvanometer or stabilizer or voltmeter or ammeter. Such sensitive instruments can be protected from this external influence.